Login accepted.
So it was a true challenge to find a suitable picture for the first slide of this talk. I didn't want to do it myself, so I asked our marketing geek for help. The initial idea was quite obvious. We also tried emojis, but then when we saw this gorilla made of cheese, we knew that this one was going to be the thing. So hello everyone, and welcome to this session where we are going to look at some similarities between two seemingly unrelated fields, which are emergency medicine and software engineering. My name is Jacek Kunicki. I'm a software engineer at Software Mill, where we've been remote from day one. We also value full trust and transparency. If you'd like to learn more about that, or even join us, feel free to catch us at our booth here at the conference. So I'm Jacek, and I usually avoid the About Me slides, but this time is different. I have to start this session with a short but very important disclaimer. So you've probably already noticed that there will be some stuff about medicine here, but I'm not a paramedic. I don't have any medical education, but still all the medical stuff that I'll be talking about here is evidence-based, so those are the facts that I'll be showing here. So if I was not a software engineer, I would most probably be a doctor. A couple of years ago, I started my adventure with first aid and emergency medicine beyond the basics. And as I started to follow blogs, read articles, I discovered that there are actually a lot of similarities between medicine and IT, or our field, especially when it comes to something that we in our IT area call the software craftsmanship, which basically means doing our daily tasks better. So without further ado, let's see what I've discovered. During the Second World War, the inhabitants on some islands on the Pacific were surprised to observe that there are airplanes bringing some kind of cargo, like food, weapons, clothes, things like that, for the soldiers who were deployed there. And since the inhabitants of the islands were not really familiar with any advanced technology, like airplanes, for example, they were sure that this cargo must have come from some divine forces. So after the Second World War has ended, and the troops departed the islands, the inhabitants thought that maybe if they start imitating the behaviors of the soldiers, they would attract the divine forces and make the cargo come back again. So what they started doing was actually try to build some infrastructure that resembled what they've seen and what the soldiers were doing, and they started to building mock-ups of airplanes, mock-ups of airports, like flight control towers or runways, for example. And such behavior, where we blindly follow some other people doing stuff without really understanding what they have been doing, this is called cargo cult. So this is an emergency blanket, or an NRC foil, as you may know it under this name. And this is used for preventing heat loss. So when you encounter a casualty and they need to stay in place for some longer time, you grab this emergency blanket from your first aid kit, you cover the person with it, and you're done, right? Well, not really. So this is a picture from a thermographic camera where the brighter spots indicates the warmer areas. So the brighter the spot here is, the more heat. And you can see a person here who was covered by an emergency blanket, and then they have been rolled to their side. So we can see the back of the person, which is hot, and you can see also some hot areas on the ground surface. And this is what actually happens if you cover someone with the emergency blanket but don't isolate them from the ground. So this doesn't really work, as we can see here, and this is a proof. But nevertheless, a lot of first aid courses would teach you to only do that. Even more, even professional paramedics are also doing that too, although it doesn't work. Why? Well, because they have always been doing so. They were always told to do so, and they have never checked the evidence. So they never check whether this really works or not. So you may wonder how this is related to IT. Well, this is Spring Framework. So probably most of you have been using that. And for those of you who have you ever wondered what's the benefit of having a framework calling the constructors for you? Have you wondered what's the price of this additional complexity that the framework is bringing? For example, having a proxy for each bin that your framework is managing. Have you ever considered calling the new method by yourselves? I mean, is there something inherently wrong with calling the constructors yourself? How about adding some additional layers of complexity to your software? So if you add those layers, does it really improve your software? Does it still make your software only do what is expected to do in terms of the business functionality? Or is this actually bringing some more problems, which you sometimes don't have control of? This is Java Persistence API. So when was the last time when you have written a plain SQL query? And is there anything wrong with writing plain SQL? I mean, when you need to fetch a user from a database by ID, do you really need this entire Java Persistence API, and do you need some magic library, do it for yourself? If you are using a relational database with Java Persistence API, are you sure that the transaction boundaries are where you think they are? Because you are putting this transactional annotation somewhere, but do you know the transactional boundary is actually there? This is another example which probably looks familiar. So probably a lot of you have been using Scrum as your software development process. But are you sure that Scrum is actually solving all your problems? And is this the right tool for your job? Or are your teams using Scrum only because everyone else does? Well, I would argue that in most of the cases, there are some simpler alternatives to Scrum. For example, Kanban, or the so-called Scrum but approach, where you take Scrum, but you either remove or add something depending on your needs. I would also argue that going 100% by the book with Scrum, for example, is not really agile, because agile is about being flexible and adapting to the changing needs. So I'm not saying that you should be avoiding using frameworks like Spring or Hibernate at all costs. But what I am saying is that you should ask yourself why you are using a given technology. And you should be honest to yourself when you answer this question. So if this is an informed decision, if you have good reasons for using Spring or another framework, that's perfectly fine. But don't use those frameworks only because everyone else does. So question why you do stuff. So what we see here in this picture, it's a procedure called intubation. And this is applied whenever there is a risk that the airways of the patient are obstructed and it's not possible for the air to go to the lungs. So when this is the case, you take a plastic tube, put it in the airways, and it ensures that there is airflow to the lungs. The tricky part about intubation is that if you do it incorrectly, that the air doesn't get to the lungs, but it gets to the stomach instead, which is not good really, because it doesn't solve the problem of the air not getting to the lungs. And it turns out that there is a very simple way of checking whether this procedure was completed successfully or not. And this is by measuring the amount of carbon dioxide that the person is breathing out. In this picture, this is denoted as the EtCO2. You can see it in the warning message on the top and in the graph at the very bottom. But still, although this is a very simple and reliable way to do it, not many paramedic teams are doing that actually. They are either not checking whether it has been done correctly, or they are choosing some less reliable ways to check it. So does this already look familiar to you? Well, imagine that you have just deployed your application to production. You have started it, you look at the logs, and they are clear. So it's perfect, right? But are you really sure that the application is working correctly now? I mean, you know that it has started, probably the port was bound, and you have network connectivity. But is the application really serving its business purpose? Is it doing the stuff it should be doing? And is the logging working at all? Do you know it? So as a mitigation to that, you start adding metrics to your application. And you start with something very simple. So you take some existing library that gives you, for example, memory and CPU metrics. You add it to some kind of dashboard, and you're good, right? Well, it's better than only having a log file, but this still doesn't tell you a lot about whether your application is functioning correctly from the business perspective. You can even take some broader set of metrics, like those here, but they are still related to some very specific framework. So without digging into much detail, those are some detailed metrics from akka, which apart from resource usage, give you some information about how the actor system is performing, where are the messages between the actors. But this is still very technical. Those are not business metrics. They don't really tell you anything about your application serving its purpose. This dashboard is a better one, because there is still a lot of information if you look at it from your distance. there are still some technical infos, but if you zoom in, there are actually places where you have some business information. So for example, here you have some information about which endpoints are used how often, what are the latencies, what are the error rates. You can also see places where we have information about errors per endpoint, or the graph on the right, where you have the 400 something and 500 something errors. So this already tells you whether your application is doing its job. And it's much better than only having the strictly technical metrics like resource usage, for example. So certainly, the more experience you have, the more trustworthy the applications you write are. But still, it's very important not to trust what you have written in 100%. So it's good that you trust yourself. It's like you should believe in yourselves. But you should also verify whether what you have done is correct or not. And you should have a proof that what you have done is actually working. Like believing so it's not everything. So now I'm going to show you a short video. There will be an introduction and there will be a task to do when watching this video. So please read the task. Please watch the video carefully. So it turns out that for people who are not familiar with this experiment and who don't know what it's about and who have seen the video for the first time, that 50% of the people didn't notice the gorilla, which was actually there. So this is another example of an experiment. What you see here is a computer tomography or a CT scan of human lungs. And this was pictures like that were given to a group of radiologists, and they were asked to do their daily job, so what they do every time. They were asked to look through those CT scans and look for signs of cancer in the lungs. So it turns out that 83% of the radiologists who went through sets of such images didn't notice the gorilla, which is in the upper part of the lung on the right. What I'm trying to show here is that when you focus too much on one thing, you can become partially blind. And actually, you only see like a part of the problem that you are solving, and you are not seeing the context, which may be harmful at some point. So, for example, translating this to our IT world, when you try to debug a problem in your application, it sometimes happens, and it often happened to me, that I was so focused on like a single piece of code or a single class in my code base, or on a single path in the flow of my program, that I forgot about all the surroundings. And then at some point I was getting frustrated because it turned out that the path that I took was actually wrong, and the solution was lying somewhere else. So whenever you encounter a situation like this and you feel like maybe you have taken the wrong way, this is the time when you should go back, have a broader look at the problem, maybe ask your colleague to help you and to discuss the problem, in order not to get too blind and to avoid something that we call tunnel vision, so only focusing on a very, very narrow part of the problem. Imagine that you are using a library like, I don't know, Akka, for example, and you are solving some problems in your application using Akka. And then you solved one problem, it was fine. You solved another one, it was fine. Then there is a new problem that you need to solve. And when you look at it, like you think that, well, I have Akka on board. Maybe this problem is really not related. Maybe there is a better tool to choose it. But actually, I don't want to include any new dependency in my application. I would like to actually try to solve this using Akka because I already have it. The problem is that at some point, this solution using the existing tool you have might be too complex, it might not be too intuitive, especially for the people who will be maintaining this code after you. So it's important to remember that having a single tool like this golden hammer is not always the solution. So you should always be aware of the context of the problem that you are solving. And this cognitive bias is called either a golden hammer or the law of the instrument, and it is about relying too much on a familiar tool. So if you hold a hammer, even this screw in this slide would look like a nail. But it shouldn't. You should choose a different tool to solve this kind of problem. So don't miss the gorillas. If you feel that you have gone too deeply in a single way of solving your problem, go back, look around, and see if you could do it somehow else. This is a picture taken in this is an actual wall switch from some hospital. For the non-English speakers, like the word on the top is alarm, which is probably familiar. It's about sending a high priority notification. The word in the bottom is light, so you are using this switch to turn the light. So the question that I would like to ask here is like whether someone presses the incorrect button. Is it actually the fault of this person because they have done this incorrectly, or is it actually a system error? Like system error meaning that this process was designed incorrectly, and this could be avoided. And now just imagine like what you do when you go into the room in your flat or house and you want to turn the light on. Probably you're not approaching the switch and like looking precisely which I want to press. You just like put your hand somewhere, you know where it is, you press it, and it's done. So doing this in a situation like that could have some serious consequences. And this example represents some vulnerabilities that we can have in our processes, in our tasks that we are doing daily. And I'd like to talk a bit about how we can avoid those. Can you imagine using this kind of clothing in your workplace? Like, for example, if you have a developer deploying something to production, they are wearing this vest saying, "Do not disturb, I'm deploying some critical stuff to prod." Well, probably not, but still you can think about some measures to avoid distractions when you are doing something very serious, like turning your notifications off and stuff like that. And this is all about putting some additional security layers into our daily job. And this is not only about security in a strictly technical meaning, like not putting firewall in your application using SSL or stuff like that. This is also about securing the processes. So like thinking how we do things, and perhaps we can do them in a bit safer way. So why is it important at all to have many security layers? So look at this slice of piece and imagine that the holes in this slice of piece represent some vulnerabilities that you have in your processes. And now if you take a couple of those slices and put them next to each other, you can imagine that when you have some hazards that are coming to your process, your workplace, to your application, they would try to go through all the layers of security, but they would be able to pass through only if the holes in all the security layers were aligned. So there is a single example of that here. But in other cases, the more the security layers you have, the greater is the chance that the hazard would be stopped somewhere, because it would pass through a single hole but would be stopped by another one. So this is really about having as many security layers as possible. So let's have a look at some examples, like how we can apply it to our daily life. Probably most of you are accessing some kind of databases in your daily job. This could be, for example, a production database that you are browsing to get some data. We have databases in other environments, like our local one or in a staging environment. Those are not that important, but if you think about breaking a production database, well, this is not really a good idea. So how about, as a way of, one of the security measures, making the access to a production database read-only by default? And there are different ways to do it, like depending on the database, you can have a user who has read-only rights. You can have, if the database is distributed, you can connect to some kind of replica that is read-only by default. I would argue that most of the queries you are doing to the production database are usually reading data, not writing, because like you have the write processes coming from somewhere else. So I would advise to always have the read-only access by default and only turn the write access on when you actually need it. Now imagine that you are working on a different set of environments and executing some commands from your terminal. Usually those environments, like the production one, the staging one, or your local one, would look similar, well, because they are usually a copy of each other. And then what happens if you like use the wrong environment, like you were sending the commands everywhere and you hit enter in the wrong terminal? Well, this could break things. A simple solution against that is to visually distinguish the environments in which you are at the moment. So you can use some very informative color, like red, for example, for the production environment, and some other colors for the rest of environments. And this doesn't necessarily need to be the tab color in your terminal. It can be, for example, the prompt. And then you can write a script that, for example, when you connect to a given server, matched by its name, for example, it would change the color of your command prompt and it would be red. It would strike your eyes and you would know that, hey, this is production. I should really be careful with what I'm doing. Speaking of deleting things accidentally or running the incorrect command, many of the tools you are using have some kind of a dry run mode, which tries to do the changes that you are attempting to do, but it doesn't actually make them. It gives you a list of what would be changed. And this is particularly useful when you issue a command where, for example, you operate on a file system and you are deleting or syncing, for example, a number of files. You are using some kind of wildcards and a lot of files might be affected. So this is a really easy way to be on the safer side and just to preview the changes that you are going to do before you actually do them. Because we are using autocompletion in our terminal. So you are typing the file name, you hit tab, then you hit enter, and then it turns out that like the autocompletion suggested something else that you thought it did. Or, for example, you used a wildcard in the file name and you forgot about it. And then instead of deleting the entire production server, well, the contents of its file system, you could see that it would be deleted and prevented by using some kind of dry run mode. Another way to avoid some kinds of mistakes, which can be thought as another security layer, is the naming of things. So this is a perfectly valid method that could live in some of your services. It's fetching a user by ID, so you get the user ID, you are delegating the call to the data access object, and that's fine. But imagine that there is a new requirement. It may seem strange, but this is only for the purpose of this example. And the requirement is that while fetching the user by ID, we should also activate it somehow. So make some change to the entity that we are fetching. And imagine that the person who was maintaining that, well, they added the activation logic, so there is this new call to activate user, but they forgot to change the method name. And now another developer comes, they are using this method, and they see the name, well, find user by ID, so okay, it's finding a user by ID. They don't really look at the implementation because, well, the code should be self-descriptive, self-comment. We all know that. And by doing that, you can realize at some point, and hopefully it's not in the production environment, that actually the logic of the fetching was not only doing the fetching, but it was doing something else. And this could be prevented by just maintaining the code and maintaining clean names. So we certainly have holes and vulnerabilities in our processes that we are using daily, and we have ways to prevent them. So try to think like what you could improve in your process, in your daily tasks, to add some more security layers, to limit the probability of the hazards passing through all of them. And the more you have, the more of them you have, the safer you are. This is actually a checklist. So this is a reminder which questions you should ask when you encounter a person to whom something has happened, but you don't really know what it is. I'm not going to dive deeper to what it is about, but there are a few steps that you need to ask, the questions that you need to ask, and this is to organize the way you do it. But why use checklists at all? Well, imagine you are going shopping. So how many of you are using some shopping list when going shopping, and how many of you are not? Well, I do it sometimes I don't. But I know that when I have my shopping list, this is really handy because, like, especially if I know the shop I'm going to, I know where everything is. I'm going to the checklist and I'm done. And if I didn't have a shopping list with me, there is a risk that I could forget about something obvious, but it could be also critical. So I'm throwing a huge party, I'm cooking a big meal, and then I forgot the most critical ingredient. So this is not nice. And checklists, or like the shopping list here, are especially useful when you are working under some kind of pressure, because then your memory can become faulty, and we as humans tend to omit things, even some things that are very obvious. And you can also think about checklists not only about when you're going shopping, but for example, when you do something that consists of a set of steps, and it's a critical process. For example, you deploy for the first time to a production environment, and you need to have some steps written down, like what to do. So, for example, you need to put the system in maintenance mode. You should do the actual deployment. Then you should do the smoke test to see whether the most critical functionalities are working. And if you don't write it down, you could easily forget about something. Another example might be migrating some kind of very critical data. Like there are also some steps that should be done, and none of them should be omitted for the entire process to be successful. So what makes a good checklist? Well, first of all, it should be short. Of course, you shouldn't skip any critical steps, but they should be as short as possible. They should be concise, and it should be clear what this step really means. Another very important feature of a checklist is that it's verified in a real situation before you actually use it. So it happened to me a couple of times that I had a checklist for some critical process like deploying to production, and then I was doing this deployment, I was going through the checklist, and then at some point I realized that actually there is no logical connection between, I don't know, point 2 and point 3. And what to do then? Well, if this is not too late for doing the missing step, that's fine, but perhaps you have already done something that prevents like fixing the situation you are in. So you should really verify the checklist that you have in like a calm environment without all the pressure that you have while deploying to a real environment, for example, so that you know that it's actually easy to follow. A good solution for that is to give this checklist to someone else and ask them to do this process, like a dry run of the process, but following your checklist, and like don't think, just do what is written here. And they will tell you whether it's concise, whether it makes sense, whether all the steps are logically connected. A checklist should also be used consciously, and this means that you should not only like manually go through the steps, you should have a way of confirming that you have done each of the steps. So you can either do it by printing the checklist on paper and then just ticking with your pen the subsequent points that you have done. You can work in pairs, for example, and then like you are the person who is doing stuff and you are telling what you're doing, the other person is confirming that this has actually been done. Because if you don't use this consciously, if you just like quickly run through those steps, you might also forget about something. This problem has been solved in an interesting way on the Japanese railway, where they have a system called pointing and calling. And this works like that. So whenever they notice a sign, for example, like the train operator notices a sign, they need to point at this sign and say loudly what's written there. So if they encounter a speed limit, for example, they are saying speed limit 60, and they have to say it loudly. And this may seem weird, probably, but if you think that thanks to this solution, they are able to avoid some serious accidents where people may die, this can actually make sense. So of course, maybe this is not a perfect solution for our IT jobs, but this, on the other hand, it's quite similar to a situation where you are working in pair with someone else and you are loudly saying what you are doing, and they are confirming that you have done something. And then you're safe. So our memory, our brains can be faulty, especially under pressure. And checklists are your good friend here, because you are never going to remember about everything that you needed to do, and you don't want to omit any critical step. So far, I have spoken about ways to prevent errors, but the truth is that we are not able to prevent all the errors. Errors or mistakes will always be with us. So the thing is that we should be able to handle situations where an error has occurred or where someone has made a mistake and try to learn from it. So this should be an opportunity to learn, especially to learn how to avoid this situation in the future. Of course, the consequences on errors can be much more serious in medicine than in IT, because in medicine it may cost someone's life. In IT, unless you are developing some life-saving software, this is usually about someone losing money. It could be a big amount of money, but it's still not someone's life. But still, even though the consequences can be different, we can use similar techniques to deal with situations where an error has happened. So one thing to look at when you analyze situations when something has gone wrong is retrospectives or debriefing. So whenever you are done with some like milestone in your project, you should gather the people that were taking part in that and discuss what went good, what went wrong. There are actually two things that are critical here. The first one is honesty. So you should be like honestly saying what was good, what was bad. The other one is not blaming other people. So the retrospective is not about saying that person A has broken everything and it's your fault, we are firing you. This is about saying that someone did something wrong and we would like to think together how we could avoid this in the future. So for more than a year now, most of you have probably worked remotely. But a key thing is that remote work is not an excuse for not doing retrospective. The slide here is actually a screenshot for a retrospective we did at Software Mill at the beginning of this year. It involved, I think, like 50 or 60 people. We did this online, and it went surprisingly good. And this is not like a single universal recipe for a retrospective. You can start really simple. You can start with like writing down pros and cons. Here we have some additional dimensions that helped us organize the information that we were gathering. But it doesn't need to look like that. You can try really simple and then evolve as you go. So when we have already accepted then that things might go wrong, we should be prepared for that. And by being prepared, I mean having a plan B, because if the approach you are taking fails at some point, you should really be prepared to roll back quickly and to have an alternative solution. So in one of the projects I was working, we had a situation where like we were doing regular deployments to our production environment and everything were good. And then at some point, our customer called us and said that like there is a problem with the release we made recently. It was Saturday. We thought, okay, let's do a rollback, and then like we want to do damage control, stabilize the production environment, and then when we come back to work on Monday, we'll see what actually happened. What surprised us was the fact that it took more than an hour to do the rollback. Although theoretically we had all the artifacts, like we should have had this the previous version of the application somewhere as a jar, or this time probably as a Docker image. So you should be able to do it almost instantly. Like you roll back the old image, you deploy the new one, and you're done. In our case, the problem was that our CI environment was executing some very long-running integration test every time it was built. So we had to wait like almost an hour for the new image to build and then to deploy. Of course, the first thing we did after that was introducing a way to do quick rollbacks so that the rollbacks takes 5 minutes and not 2 hours. So it's really important to have a plan B, to be able to roll back quickly if you break something. And you will break something eventually, so it's really a good idea. So imagine a developer coming to their manager and saying that we have a problem. But the manager answers that actually there are no such things as problems, there are only opportunities. So the developer says, okay, so we have a DDoS opportunity in our production system. Well, funny as it may seem, this actually passes a very important message, because every time an error happens, it's actually an opportunity to learn for us and to think how we can avoid this in the future. And there is a nice procedure which should be followed when you encounter an learning opportunity like that. It's called postmortem. And once again, postmortem in medicine is a very serious thing because it means someone has died. In IT, it's not that serious, but it still helps you to avoid the problems in the future. So while writing down a postmortem, you should focus on a couple of steps. The first thing that you should focus on is a timeline. So you should write all the events that led to this problem. This could be done with timestamps so that you actually know what happened and you can follow the flow of events. Then you should describe the actual problem, what the consequences were, what was the root cause, but also what was actually broken. You should also write down how you solved this problem, so that when people read it, they will know what was done, and maybe this information would become useful in the future when someone encounters something similar. And if you have any other ideas how to prevent such a situation from happening in the future, this should be also written down. And it's also important to note some action points, because this entire postmortem without any action points is not really worth a lot. So if there are actions to be taken by particular people, you should assign the people to take those particular actions. You should have timeline for that, so that everyone knows what they should do and when. So the errors and mistakes will always be with us, and our goal is to learn from them. In one of the projects I was working, our team leader was saying that we don't have errors in our production environment, we have opportunities. And opportunities to learn. And this was really nice, because this was really safe for us. And what we should be doing is building something that can be called a safety culture. So an environment where people are not afraid to make mistakes, because they would always be with us, and we should just learn to live with them. So in one of the projects I was working on, I heard a story from one of my colleagues from their previous company, where when a developer introduced a bug into the production system, and well, they broke something, they were asked to fix this bug in their free time. And to me, this sounds inherently wrong, because this assumes that like we are perfect, and whenever like we are paying you for writing perfect code, and if you don't write perfect code, then you should fix it in your free time. Well, I would argue that it's better to accept that we are going to make mistakes, and we should have a culture, like this safety culture, where actually people are not afraid to make those mistakes, but rather learn from them, because this is unavoidable. So to summarize what we've seen here, you should be avoiding cargo cults. So you should be thinking and questioning why you are doing things. You shouldn't blindly follow other people. And it's not that you shouldn't be using tools that other people are using, because this is fine, but this should be an informed decision or a justified choice. When you do something, you should believe in yourself, because all of you are good developers, but you should have a way to verify what you are doing. So you should have a proof that the solution you created is really working. You shouldn't become blind, and you shouldn't fall into this trap of this tunnel vision. So don't miss those gorillas from the video we saw. When you feel that you've gone too far on the wrong path, come back, take a look around, ask other people for help, because if you lose the context, if you blindly focus on a single solution, this may lead you to a wrong place. In order to avoid the errors, we should be introducing as many security layers as we can. And once again, this is not only about the technical layers, like adding SSL, adding firewalls. It should be also about introducing security layers to our process. So thinking how we are working, looking at our development process from a bird's eye view, and then checking like how can we secure it. Because the more security layers you have, the safer you are, because the lower is the probability of a hazard passing through all those layers. As one of the measures to avoid errors, you can use checklists, which help you especially in situations where you work under pressure. Whenever you have a sequence of steps to do, you are very likely to forget about something, even if it is something very obvious. We can argue that the more obvious the thing is, the easier it is to forget about. And checklist done right would let you avoid such kind of situation. And you should build a safety culture where mistakes and errors are accepted, because those are things that are unavoidable. And you should be able to handle situations where a mistake or an error happened, and you should introduce a culture where people are encouraged to learn from that. And this is about doing continuous deploying to production as often as you can, assuming that you might break something, and just be prepared for a situation when something is broken and be able to learn for it. And while looking at this summary, maybe you have an impression that like those analogies are similar also to some other fields, not only to medicine, because this sounds very universal. So this means that you shouldn't really be limited to IT when looking for ways to improve how you work on a daily basis. If you have friends working in some different fields, talk to them, learn how they are dealing with different situations, learn what best practices they have. Because as you saw here, even if the fields are seemingly unrelated, there may be a lot of analogies, and you might actually be able to learn from people doing something completely different than you do. Last but not least, I'm not allowed to give any first aid training here, because I don't have qualifications for that. But I want to pass two important messages about this. So first of all, first aid is mostly about noticing that someone might need help. You don't really need to be trained. So whenever you see a person who looks like they might need help and you are not sure, just approach them and ask. And if they need help, if you don't know what to do, act. It's enough to call for help, and someone will come there and help them. So this is very important. And also the statistics say that if at some point you are going to need to help someone, this will probably be one of the people who are closest to you. So it's very important to know what to do in such a situation. because you may save life of your closest one. So take a first aid course whenever you have opportunity to do that. Thank you.